Okay, so this is going to be a tutorial on the NS4 method, which was invented jointly by me, SugarCubeSolver, who's me, and then Neuro on speed solving forums. So, first we let's just go and scramble up quick. So, first step, like most speed solving methods for 4x4, is to solve two opposite centers. And unlike roux or roux-based methods where I do blue and green, I do red and orange because I do blue and green on front and back for, actually orange on left, for ZZ methods. And this is a ZZ method, base method. So first you want to get one center and the other, or whatever, however you do it. So now you've got two centers. And now you want to solve both of the line edges that will go in your EO line, and then one other cross edge, and then one just random E-slice edge. So, but make sure it goes in the E-slice, which is pretty easy to find, because because of how it works. So, what I would do is probably do that. I see these two pieces, so you want to make sure that the line edges are right here, here, and here. So this one's right here, and this one's right here. And there's an oriented E-slice edge, and then there. So you want to make sure that you have this kind of thing like in Yao. There's three cross pieces, but then also this piece. So you can still do like that and that, but this piece limits your movement a little bit, but not by very much. So now you do last four centers. So there's that. So there's that. So then last four centers, and now you want to go and kind of resolve the cross a little bit. So like you have the 3/4 cross, and then solve your last crossed edge, which in this case is this one right here. And also it's usually good form to go and pair up another edge here, just because of how this method works. Because you don't want to just go and waste a slice move, so pairs up this crossed edge and this piece right here. So now you insert this cross, and then with this oriented E-slice edge that you made earlier, you want to make a pair and place in one of the two back ones oriented. Sometimes it'll be this one, but sometimes, let's pretend this pair goes here, you'll have to go and put it in the wrong pair, in the wrong slot, but you don't want to put it in one of these back ones. So now let's get into EO pairing, or that's the original way of doing it. The better way of doing it is a little bit simpler, so it's pretty much two at a time edge pairing, but you try to influence when an edge is oriented or not, and you also want to make sure that you have all edges oriented at the end. So you want to do two at a time edge pairing, and then if edges are not oriented at the end, you want to go and orient them using extra moves, usually like a rotation, then an LU, L' insert, or something like that. So let's make an example of this. So I have this orange yellow piece and this orange yellow piece, and now there's two ways I could slice. I could do that, which would make this one misoriented, or I could do that, which would make it oriented. So I'm going to do this one, and I see this piece goes right here, and then I have this piece misoriented, but I oriented this piece, which is a good thing. So this piece, instead of like just keeping it like here, I would insert it there so that it's an oriented piece like that. So now let's do another one. So these two right here, I can do that, but I want to do this because it keeps them oriented. And then that one's good because that one keeps that one oriented as well. So how many other pieces do we have? Only two more pieces. Okay, so let's see, how many flipped edges do I have? So this edge pairing algorithm, the one that goes slice that, the one that you usually use in Yao, will flip the edges that are on this top part, not this bottom one. So you can use that to force cases. So like right here, I see, I want to put this piece back. So like see these, this edge is not flipped, and if one of these edges is oriented, then I will take the other edge and do it from that angle. So like right here. And because mostly out of habit, I will do this, and then I will do it as a commutator, so I'll undo that move. So now I've got these two are flipped, and are any other else flipped? No, I don't believe so. So then I fix the EO of these two, and this is also be the time that you would recognize parity. So now I've got that, and then I will have either a full EO X cross with this piece, or I will have a pseudo EO X cross with the piece like that in the back. So you want to go and insert that piece, and then do ZZ F2L. It actually is more like rotationless F2L, which is also like probably the fastest 3x3 stage of any other method. So there that is. And then so now you want to do CO. So now you have the last layer. Because 4x4 has parity, I would heavily suggest using COLL. That was just the pseudo CMLL. And then EPLL plus parity. So this algorithm is an EPLL plus parity algorithm. There's only like 4 more algorithms you know besides the pure parities, and they're just mirrors of each other. So this one right here is a H perm with parity. So this one is and there you go. So yeah. So if you use EPL plus parity, you will get a 2-look last layer every single time, because you already did OLL parity. And EPL plus parity means that you will always solve parity during EPLL. So you'll either get a 2-look last layer or you'll get a skip, which is also nice. So thank you guys. That's the tutorial.